We've done a lot since the last review video, and remember that the overarching goal of all we've done since then has been to get the fly to fly to a random position on the screen, and once it gets there, pick a new one and fly to that new one and continue doing that. The first thing we had to do to achieve this is figure out what the screen size was, and we did that with this getScreenSize method on the default toolkit. And the first thing we did is just put that out to the console so we could verify it was behaving as expected. And we also stored the screen size in this instance variable so that we can reference it later on. Next thing we did is we used that screen size variable to actually find a random position on the screen. The way we did that is we multiplied the width by a random number between 0 and 1 to get a random x coordinate, and we multiplied the height by a random number between 0 and 1 to get a random y coordinate. Then we also added this destination instance variable, and that's going to store the destination that the fly is flying towards. And we added a setNewDestination method that will get a random position and set the destination equal to that random position. For tracking purposes, we also output it to the console. So the next challenge we came up against was, we have a random position, how do we actually advance towards it with each iteration of the animation loop? And so we did some geometry to decide that we need to know the angle between the fly's current location and the destination to know how much to update the x position and the y position by with each iteration. So we wrote this messy method to get the angle between 2 points from and to, and then immediately after I told you it could be done much simpler if we just use this additional atan2 method on the math class, so we did that instead. It's still not immediately obvious that this method is going to perform as expected, so we wrote some tests to confirm that it is doing what we think it should be doing, and it seemed like it was passing at least these two test cases, and you should have written some more. So now that we're able to get the angle between 2 points, we know what the update logic needs to be. We need to get the angle between the fly's current location and the destination. And to make that easier to do, we added this getAngleToPoint method, which just delegates to the getAngle method and passes in the fly's location as the first argument. And once we have the angle to the destination, updating the x-coordinate as simple as multiplying the velocity by the cosine of that angle, and updating the y-coordinate is pretty similar. We just multiply the velocity by the sine of that angle. And we put this negative sign there because of Java's weird coordinate system. We also changed the location from an array of ints to an array of doubles, because now that we're no longer moving in a simple line, it's not guaranteed that the increments to x and y each time through the animation loop are going to be integers. They probably won't be. So we had to do a couple of updates to accommodate that change. Specifically, the setLocation method on the JDialog takes 2 ints as arguments, so we had to convert the location to an int, because ultimately it's going to show up in pixels, which are discrete units. All right, finally, so at this point, the fly is flying to its destination, but once it gets there, it just vibrates around it. It doesn't move on to a new one. So we had to add some logic to detect when the fly reached the destination, and when it did, give it a new one. So that's what this checkReachDestination method is doing. And remember, we had initially, for our implementation of this method, just compared the location of the fly directly to the destination. And we found that that was far too sensitive because the fly never actually reaches the destination, it just gets close to it. So we had to come up with another geometry method to measure the distance between 2 points, and it looks very similar to the getAngle method. And so we call that in our checkReachDestination method. We get the distance between the location and the destination, and we do that with another utility method that looks very similar to the getAngleToPoint method. It just delegates to the getDistance method and passes in the location of the fly as the first argument. And so we compare this distance from the fly's current location to the destination to this static variable close tolerance. And this is a measure of how close we have to actually get to the destination before we consider ourselves there. And so we said 10 would be a pretty conservative number to use here, since the fly's position increases by 5 pixels with each iteration of the animation loop. And so after this, we could detect when the fly got close enough to the destination, and when it did, we would give it a new destination and it would fly off towards that. So at this point, the fly picks a random position to fly to. It flies there. Once it gets close enough to it, it will pick a new destination and fly towards that, and so on ad infinitum.